Hey everyone, back tuning in to the 10th and final Winter 2015-2016 update from GazWebBiz.com. We've done 9 updates through the autumn. This is the 10th and final one. So for one last time, we're going to get various things together, such as solar activity, what's going on across Russia and Scandinavia in terms of snow cover, and of course El Nino and ENSO sea surface temperature anomalies. And this update will particularly be focusing on the analogues, again, from our good friend Stuart Markham from the website SurelyWeather.com. So there's going to be loads of information coming up. I've got a huge number of analogues to get through for this update, so I'm going to try and keep it under half an hour, but if I go on beyond half an hour just this once, then it may just have to do that, because I've got loads of information to get through. So, before I get on with that, just to say about the ads, there's links to articles on the page at GazWebBiz. Have a browse the widgets and click through the links if there's any articles that you're interested in. Thanks very much for doing that. There's video ads on most of the pages which open up in the content. When you watch them, they'll close back up again. It's all helping to pay for the website. And the shop is open, so if you've got any Christmas shopping to do at Amazon between now and Christmas, just click through the Amazon banners in the Christmas shop. You get to the Christmas shop by clicking the button that says Christmas shop. When you get there, there's a search widget where you can search for whatever item you would like to buy, but perhaps the easiest thing to do is just to click through the Amazon banners and go directly to amazon.co.uk. Do your Christmas shopping as normal, because you're going from GazWebBiz to Amazon, we get a revenue fee on the things that you are purchasing. Thanks very much for doing that. It's all helping to pay for me to sit here and talk to you via GazWebBiz. As I explained last week, these long videos that we do during the autumn for these winter updates, they have a bit of an effect on my vocal cords. So again, I've got my water with me. There we go. And I may have to stop and have a drink, have a little bit of a cough. Hope you bear with me if I have to do that. We are, as I say, however, nearly at the end of these updates. This is the last actual update. Next week on Sunday, we will do for one last time for this season the model roundup video for the winter. We'll get about 10 or 11 long-range seasonal models together, see what they're all showing for the winter. That'll be next Sunday week today. And then it all builds up to the final and official GazWebBiz.com Winter 2015-2016 forecast, which is going to be released this year on Tuesday, the 1st of December. So we really are getting towards endgame now with all of the updates. So, well, for the final time, let's get on with it. And we're going to start off a little bit different to most of the other updates that we've done. Actually, I'm going to start off with tropical activity in the Atlantic Ocean. Just to say, there's been very little activity in the past week since we did the last update. So, I think it's about over now this season, really. We've had 12 total depressions, 11 storms, 4 hurricanes, and just 2 category 3 or above hurricanes. So it's been a very quiet Atlantic hurricane season again this year. The idea behind this, remember, is that if you get a lot of hurricanes dumping a lot of heat into the Arctic via hurricanes, that's essentially what they're doing, sort of taking heat out of the tropics and dumping them into the latitudes, eventually into the poles. You get a lot of that going on through a hurricane season. Eventually it can translate back to the chance, or an increased chance, of blocking on our side of the Arctic. We haven't really had hardly any hurricanes at all this year, so obviously this does reduce a little bit the chance of blocking as we get through into winter. Next thing I'm going to talk about is Siberian snow cover. So this is a situation across Scandinavia and Russia last week when we did the update. This is from Friday the 13th of November. And you can see that most of Russia was covered with snow by this point, but not doing all that good across Scandinavia. If we fast forward, though, to the latest image, you can see that virtually the whole of Scandinavia is now covered with snow. And that snow cover is also more or less at the Russian-European border. It's just a little way from Russian-European border, but it's basically there. Now, this is much less impactful at this time of year compared to if we was looking at this on the 20th of October. If we had this sort of chart going on the 20th of October, it really would be game on for a good chance of, or an increased chance of Siberian blocking. But it's 20th of November, so it's no more than you would expect to be seen, really, at this time of year. And quite a bit of this across Scandinavia. It's actually going to be melting, I think, during the course of the coming week. It'll be quite a mild week up there. Not for the north, of course. The north of Scandinavia will hang on to the snow, but across southern parts of Scandinavia, some of this snow cover will melt. Anyway, it's good to see that most of Scandinavia and Russia is now covered with snow. We wait to start to move that snow cover into Europe, of course. Next thing to look at is going to be solar activity. So this is the solar disk on our side of the disk today from solarham.net. Again, very few sunspots to be seen. We've got this region just here and these areas just here. Solar activity is again officially designated as low, maybe very low, from Solarham today. This may tick up a little bit over the next day or two, perhaps reaching moderate levels, I'm not sure about that, but generally it is quite a quiet period on the sun. We're going down into solar minimum, as we know. This is the running graph of solar activity from last winter to present from our good friend James Zackrill, who has been supplying us with these charts, all of this information in terms of solar activity throughout all of these updates. And I know you'll be watching, James. Thanks so much for all of your help this season. Again, I really couldn't do these updates without the information that you and Stuart sends to me. So a huge thank you to both of you, actually, for the help and all of the charts that you supplied us with, again, during this season. So this is where we are in terms of solar activity right now. On this graph, we're in that sort of zone just there. Quite weak activity, so that's a reason that day by day solar activity at Solarham is being designated as low. It compares, and how it compares to last winter, is that we was in this sort of zone through last winter. So quite clearly, we've seen a downwards trend in solar activity over the past year. You have weaker solar activity this year compared to last winter. Remember, the weaker solar activity, the greater the chance of blocking over the North Pole. It's not quite well understood why this is the case, but when you've got low sunspot numbers, it seems to coincide with an increased risk of northern blocking. Particularly so for the Atlantic and Europe on our side of the North Pole. I think it's less so for America and less so for Asia, but on our side of the pole, probably via the jet stream, it does seem to have an impact if you've got low solar activity, low sunspot numbers and solar flux in terms of increasing your chance of blocking. So we're going down into solar minimum, as we know, and I speak about this a lot in these updates. I just wanted to show you this chart. This is the latest updated chart for Solar Cycle 24 from NASA. So this is Solar Cycle 24, and this just here was the maximum of Solar Cycle 24. That compares to the last solar cycle, the last solar maximum, number 23, which is just here. And the one before that, number 22, is this huge solar maximum that occurs just here. So we've got one solar maximum going on around 1990, another around the year 2000 to 2001, and then our solar maximum actually occurred, well, we had a double peak, didn't we? We had the first peak in 2011, right at the end of 2011, and the second peak, which unusually was a little bit stronger than the first peak, that occurred at the start of 2014, which is just here. And quite obviously now we are sinking down with the trend, and the trend is this sort of thick white line just here. We're sinking down with the trend into solar minimum, which occurs just here. You'll notice on these last two solar cycles that as we move down into solar minimum, we continue to get various spikes upwards whilst the general trend was down. So for example, we spike up, we go down, we spike up again, we go down, we spike up, we go down, and so on. So it's not a linear process. You don't get month by month by month just becoming weaker, you do still get spikes in activity whilst the overall trend moves down. But it just goes to show, and this is very dramatic. I'm off on a bit of a tangent. This doesn't really make much difference to the winter forecast, but it just goes to show you how weak this solar cycle is, solar cycle 24, compared to at least the last two solar cycles. I think we underestimate a little bit just how unusual solar cycle 24 is, but it is a very unusual and a very weak solar cycle. So solar activity is looking okay at this stage. No signs of things spiking up in terms of those sunspot numbers at the moment. Right, the rest of the video is going to be dealing with sea surface temperature anomalies, and particularly with El Nino. So just wanted to talk very quickly about the Atlantic. This was the last chart in terms of the oceans that we looked at for the last update. So this was generated by NOAA. It's sea surface temperature anomaly map for the world. It's generated by NOAA on the 12th of November, and it was used for the last update that we did last Sunday. So in terms of the Atlantic, this cold pool, of course, in the central part of the mid-Atlantic, and then we're looking at the Pacific, from the northeastern Pacific to be quite warm up here. And then the main thing, of course, is this dramatic El Nino signature that we have here, this warm mass of water that stretches from Peru out into the central part of the equatorial Pacific Ocean. So that was the situation with the oceans last week. Let's fast forward and have a look at the latest chart, and this is it. So, deal with the Atlantic first of all. I think the cold blob has shrunk ever so slightly, but it is still there. It is still in business if you want the Atlantic to be in a fairly cool phase. I don't think this makes a huge amount of difference in terms of getting the cold winter, but if you want the Atlantic to be in a cool phase, the cold blob is still there. A little bit less so than last week, but generally it's still in business. Things looking a little bit cooler up here in the northeastern Pacific Ocean, but it's still warmer than you would expect. This is normally a very cold place, actually. So it's warmer than you would expect, but I don't think it's quite as warm as the past couple of years. This probably does have a little bit of an effect on the weather pattern in America. It may be a little bit different to the last couple of winters. In terms of El Nino, though, let's just have a quick look again at last week's chart. This was what El Nino was doing last week. Going forwards to the latest chart, I think we're probably becoming increasingly central based with this El Nino. It's probably becoming more centered towards region 3.4, which is the central part of the equatorial Pacific, as opposed to regions 1 and 2. Somebody on YouTube pulled me up on my terminology about this. I've been saying region 1.2. It's actually regions 1 and 2 over there towards the Peruvian side. But in any case, what we've been looking for is to get a central-based Modoki, central-based El Nino, which is that it's warmer in 3-4, which is just here, as opposed to 1 and 2, which is just here. So I think we probably are shifting a little bit towards that right now. If we have a look at this chart from tropicaltidbits.com, this is a graph of regions 3.4 and 1 and 2. So, well, we're very, very intensely warm in terms of the equatorial Pacific Ocean anyway. We're very intensely warm in that central part of the ocean. We already saw it on that anomaly map, of course, that huge mass of red. We're around 3 degrees above average in that sort of zone just there in the central part of the equatorial Pacific. Whereas in 1 and 2, this is where we are in 1 and 2, and we're around 2 Celsius. So we're around a degree warmer in the central part of the equatorial Pacific as opposed to the eastern part of the equatorial Pacific. Now, this has only been going on for a little while, so I wouldn't yet say it's firmly a Modoki or Modoki central-based El Nino, but it may actually be starting to inch in that direction. It's been a very slow process to sort of get it to that sort of area, but I think we may now be inching towards, perhaps a little bit anyway, a central-based El Nino event. But in any case, it's a very, very intense El Nino, and with virtually at record-breaking levels. Now, maybe we are at record-breaking levels in 3.4 anyway. That is a huge monster El Nino, and it really is a super Nino event. Now, the strongest recorded El Nino was that of 97-98, and if you've been watching these updates, you'll know I've been a little bit concerned about 97-98 and the effect that it could have on our winter, because that was an exceptionally mild winter with that record-breakingly strong El Nino. And the rest of the chart going to look at, including this one from my good friend Stuart Markham from chorleyweather.com. Thanks so much, Stuart, for all the help and charts you've given us again through the course of this season. So this chart is comparing 1997 sea surface temperature anomalies, or the El Nino event basically, of 97-98 to the current one, 2015. So this is for region 3.4. Remember, that's a central part of the Equatorial Pacific. The red line here is where we are in terms of the sea surface temperature anomaly in the central Equatorial Pacific, compared to at this point where we was in 1997, through the middle part of 1997, which is the green line. So you can see we are actually now warmer. We've gone past 97-98 in terms of this El Nino event. Of course, this could drop back a bit, so maybe we won't beat that all-time record El Nino event of 97-98, but at this stage, we are warmer, quite shockingly so, really, to be done this, but we are warmer than the all-time El Nino event of 97-98 at this point. But if you have a look at regions 1 and 2, this is really quite dramatic, because you see that we are substantially, significantly cooler in that eastern part of the Equatorial Pacific compared to where we was at this point in 1997. So you can see that in 1997 we was actually between around 3 and 4 Celsius above average in that sort of zone just there, and even going above 4 Celsius above average at one point in that eastern part of the Equatorial Pacific around this time. Whereas now, look at this, we are significantly below with that red line. We're significantly cooler, so around 2 Celsius, somewhere around, or maybe a little bit under 2 Celsius above average in terms of that anomaly at right now in terms of the East Equatorial Pacific. Whereas look how much warmer we was with that green line at this point in 1997. So it's going to be interesting, actually, when we average it all out, to see whether this El Nino event does beat 97-98, because whilst it's warmer in 3.4 at this point compared to where it was in 1997 for the 97-98 El Nino event, in 1 and 2, we are significantly cooler right now compared to the same point in 1997. And that does imply that we are probably going towards, anyway, maybe not there yet, but we're probably going towards a Modoki central-based El Nino. Quite interesting, that information. And it does sort of take away the concern that we've had a little bit about 97-98 in terms of the analogues for this coming winter. This chart is just reaffirming the difference between the two events, 97-98, or where we are right now in terms of this event compared to where we was at this point in 1997. So you can see that the central and western part of the Equatorial Pacific is warmer now compared to 97-98, but look how much cooler it is over in the eastern Pacific, around this Peruvian coast and going down towards Chile. Much cooler in that eastern part of the Equatorial Pacific compared to 1998. So that does start to take the worry of 97-98 out of the equation just a little bit. So let's have a look at some analogues then, and we're going to deal with El Nino events. So first we're going to look at general, just basin-wide El Nino events. And what that essentially means is that it's as warm in the east as it is in the west. It's as warm in the west of the equatorial Pacific as it is in the east of the equatorial Pacific. So, you see what I mean? There's no differentiation between one region to another. It's just a general El Nino event, moderate to strong El Nino event, from one side of the equatorial Pacific to the other. And this is what the analogues yield for those years. Actually, there's not all that many of them that have just general basin-wide El Nino events with no deviation between the regions. We've just got 4 of them, 1900, 1912, 1926, 1958. And this is what the analogues yield when you compare all of those winters together in terms of the 500 millibar height anomaly. You come up with this. So it's a very unsettled signal that with a deep trough of low pressure around to west of the country. We do have some blocking up towards Greenland, but generally this is probably quite a mild signal for the winter months. I would think it's very Atlantic driven and possibly an exceptionally wet signal as well. Now, this analog chart is looking at the eastern-based El Nino, so sort of the 97, 98 El Nino end of the scale. So it's not a Modoki, this is an eastern-based El Nino, and this is what you tend to find in terms of the 500 millibar height anomaly for the winters that have eastern-based El Ninos. And you can see that it's quite an odd pattern, but what tends to happen is that you have a trough of low pressure around the UK and go a little bit to the south. But you also have this big ridge through the Atlantic. So it tends to be quite an Atlantic-driven signal. And you tend to be doing something like that. So it's not all that mild a signal. But it is a milder signal compared to the central-based El Ninos, which I'm going to show you in a moment. And it's very much a transitional pattern as well with these eastern-based El Ninos. So this is how Decembers of those eastern-based El Ninos stack up. And you tend to get a deep trough of low pressure in the Atlantic, a strong ridge around the Azores, and you tend to have a strong jet stream pushing through the country. So Atlantic driven and pretty mild Decembers in those years that have those eastern based El Ninos like 97, 98. January looks pretty awful if you want cold weather, because you tend to get a ridge around the UK and going down to the south of the country. So that pulls up the air, of course, from the south. So you tend to get very mild Januaries, actually, with these eastern-based El Nino events. If you want a cold January, you don't want an eastern-based El Nino. And then for February, you tend to find that the ridge goes more towards the west of the country, and a trough of low pressure digs into Scandinavia. So it's a little bit of a cooler signal. You probably get a little bit of troughiness within the 500 millibar flow. But overall, again, still quite a mild signal, actually, in those eastern-based El Nino years. So as we've been speculating, you don't want an eastern-based El Nino, and you don't want just a uniform El Nino. What you want is a central-based El Nino, where it's warmer in region 3.4 compared to 1 and 2. So this is the reanalysis analog chart for this is for when you have that central base Modoki El Nino. So this is looking at all the winters that have a central base El Nino. By the way, Stuart's gone back to the year 1856, can you believe, with all of these analogues. Quite remarkable he's managed to go back that far. But you see that it's a very different pattern for the winters that have this central-based El Nino signature. So you tend to get blocking through the northern Atlantic. You tend to get it strongly across Scandinavia and western Russia. You tend to get a cut-off low through the central basin of the Mediterranean. And that's a much colder signal, of course, because we've got this blocking generally centred to the north. And, of course, we're generally, with this, bringing in the air from an east or a southeasterly type direction, with that trough cut off down to the south. So the Decembers with these central base Modoki El Ninos tend to look like this in terms of the 500 millibar reanalysis. You tend to get a ridge over Scandinavia and going down into UK. So it's not too cold a signal at this point. The jet stream going a bit like that. Of course, what can happen with that is that if that ridge is far enough north into Scandinavia, you can pull in the air from the east a little bit. But overall, it's not too cold a signal for December with all of these years. But you get through to January, and look at this. It's a very, very different signal for January of these years with a central based El Nino compared to the Januaries with an eastern based El Nino. Remember, for January with an eastern based El Nino, you tend to get lots of ridging through most of Western Europe. What you get with a central based El Nino is a big ridge setting up to the north of Scandinavia, and a very deep trough here sitting to the south of it across most parts of Europe. So this is a much colder signal. The jet stream is going rather like that with this central based El Nino signal. And of course that allows the air to come in from the east, and it also pushes the cold air out of the Arctic via the north as well. So it's a much colder signal for January if you get a central based El Nino compared to if you have an eastern based El Nino. Remember, it does look as though we are shifting more towards a central based El Nino at this stage. And then even more stark really for February. So this is what February's with a central base El Nino tend to look at. You tend to bring deep troughs down from the Arctic, from the North Pole, and send them into Europe. We've got this ridging out through the Atlantic, and we've got this ridging up here to the East Europe and into Western Russia, but the jet stream here goes like that. So it's a cold signal for January and for February if you have a central base El Nino. Less so for December, but for January and February it really does look as though February's with a central base El Nino are substantially colder compared to the years that have the eastern based El Nino. I hope you're bearing with me. I hope I'm explaining this okay. But as we've been sent all the way along, this has been factoring in the updates since the first ones that we did, started September. The idea is that if you have a central based El Nino, it's a cold winter signal, and eastern based El Nino is a milder winter signal on average. So out of all of those years that Stuart has looked at in terms of El Nino, the year that has been standing out, we explained this last week, the year that stands out, the winter that stands out, is that of 1941-1942. That was in terms of El Nino and the QBO, the quasi-biennial oscillation. This is the sea surface temperature reanalysis for November 1941. So you can see the El Nino just here through that central part of the Equatorial Pacific was a central based El Nino. There's the Atlantic sea surface temperature as well. Not an exact match, not a perfect match to the current situation, but it's the closest that Stuart can find. And if you add solar activity into the mix, which Stuart has done, he believes that we are quite close with the sunspot activity right now compared to where we was at this point in 1941-1942, which is this area just here. So we was around here in terms of those sunspot numbers, which was, you can see the numbers listed there, so somewhere around 50 or 60 on this chart. So combining it all together, it does appear that the winter of 1941-1942 is the closest match when you combine El Nino being central base, when you combine the QBO being westerly, when you combine sunspot activity and the Atlantic sea surface temperature anomalies. We combine all together. Stuart has reanalyzed and came to the conclusion that 1941-1942 is the closest match for these drivers to the current situation. This was a cold winter, so this is how the 500 millibar hydrogen anomaly looks for January 1942, with lots of blocking there up over northern Scandinavia, deep trough of low pressure through Central Europe, and it means the jet stream is going like that. It's actually very close to the charts we were looking at a few minutes ago in terms of Januaries that have those central base El Ninos. It's very close to those Januaries. And really a perfect match if you like. If we have a look at February 1942, the pattern gets even more extreme with lots of ridging going towards Greenland, and then we've got this deep trough to the south, so it allows the winds to pull in from northeast. We did explain this in last week's update. So the temperature anomalies for that winter of 41-42 look like this. Generally near normal to a little bit milder than average for December. It was generally quite a mild month in December 1941, but as we explained last week, January 1942 becomes much colder, severely cold for most of Europe. We go down to around 2 to 4 degrees below average in the UK, and then February turns even colder, severely cold February, with a temperature anomaly of around 4 to 5 degrees colder than average across the UK and most of Europe, firmly locked into the freezer. If we was to repeat the winter of 1941-1942 with 2015-2016, if we did it, and it's a huge if, but if we did it, then we would be looking at a severe cold winter, because this is how the temperature stacked up in terms of central England temperature. December was mild at 5.6, but January and February 1942 very cold at 0.9 and severely cold for February at just 0.1. So very interesting analogues, of course, and I'm not by any means at this stage going for a severely cold winter, so let's just put that firmly on the table right now. We have, if nothing else, you've got to take into the fact that we've had climate change, we've warmed substantially and significantly, not just here but across the world, from where we was in 1941, 1942. But I think what we can take out of this is that there's a very strong signal here that, and we've talked about it right from the beginning of these updates, there's a very strong signal that if you get the El Nino warmer in the central part of the Equatorial Pacific, if you get a Modoki central-based El Nino, it is a colder signal for the winter compared to just a uniform El Nino, or compared to an eastern-based El Nino, particularly compared to those eastern-based El Ninos, such as 97, 98. What we've got to factor in, however, is that we are having a Super Nino in the central part of the Equatorial Pacific, not so much in the eastern Equatorial Pacific, but in the central Equatorial Pacific, we are having a Super Nino. It's a mega event, may reach record-breaking levels, but I'm not sure if it will, because it's significantly cooler in the east compared to 97, 98. But it's certainly a big El Nino event anyway. And we've got to think about what effect that will have vis-a-vis having a Modoki central-based El Nino. So it's a very complicated forecast to get together this. I'm going to have to get it together on the 1st of December. I'm going to have to produce a forecast. I've got a rough idea about what I'm going to predict for this winter, but it is a complicated one, and I don't think I'll have huge confidence in the forecast. Things could go awry with it, but I have sort of got a broad idea of where we're going for this winter, where I think we're going anyway. So I'll reveal all on the 1st of December. Well, that's it for now. How long have I gone on for? I think I've gone on over half an hour for this one, 32 minutes, so not too bad perhaps, but that's it anyway. That's the final update. Once again, I just want to say a huge thank you to James and to Stuart for supplying us with all of this information. I really couldn't do these updates, certainly not on a week-by-week basis, without all of these charts and information that James and Stuart give us. So thanks so much to both you for the help and charts that you've given to me and to Gaz over this season once again. Well, that's it for now. The next Christmas update, I think that's the 10th one, funnily enough. The 10th Christmas update will be with you this evening around 6, 7 o'clock, something like that, on the Christmas updates page. This will be going on to the winter updates page with a written summary as well, and it'll be kept around the website, so if you haven't been able to watch it all in one go, you'll be able to come back, watch it whenever you want. Next week, we're going to be doing the final seasonal model roundup for the winter. Get all the seasonal models together for one last time to see what they are showing for the winter. And then that's it. We get to the 1st of December, we release the forecast. So we're, as I said at the beginning of the video, we're nearly at endgame now for this season, and we're almost there. That's all for now. Thanks for watching.